Good morning, afternoon, or evening, depending on where you're connecting from. I'm sure there's people from all over connecting right now. My name is Matt Baldwin. I'm your host today. Thank you for joining me for our next Cloud Native online meetup sponsored by StackLink Cloud. I run this webinar every 2 weeks, and I hope you can continue to join me for future sessions as we dig deeper and deeper into Istio, its various components, use cases, and some production stories. As we did with the last webinar, I'll post the video for today's session online in the next week or so. It does take us some time to do some of the post-production work and clean things up. But if you didn't know, the last session is now online, and the link is available off of our meetup page. But before I begin, let me go ahead and do a bit of housekeeping. So first, I want to ask everybody to keep themselves on mute. I actually figured out how to use the Zoom settings right before the meeting, and I forced everybody onto mute. Cody, if you run into an issue, just DM me, and I might have to force an unmute. But please don't unmute yourselves, and we want to try to keep the audio nice and clean. Second, we will leave about 10 minutes at the end of the session for some questions and answers. So if you have a question, please go ahead and drop that question either directly to me in chat or go ahead and drop it into the group. And at the end, I'll go ahead and ask those questions to Cody, who will hopefully be able to answer them all. If we can't answer a question, we'll go ahead and find the answer for you, and then we'll post the answer to the meetup page afterwards. So also stay tuned after the webinar as I try to announce the next meetup a few days after this one. And for the next ones, we're going to start transitioning into production deployment stories. We actually found a company who is brave enough to actually talk about their production use of Istio, which will be very interesting to hear about. But today we have Cody McCain. Cody carries the Tigera flag in New York City, where he helps customers connect all manner of things to the fabric. Prior to his current role, Cody provided Kubernetes training and implementation services at Apprenda. Thank you for joining us today, Cody.
Well, thanks for having me. It's a pleasure to be here. When I got the topic on Istio Service Mesh and doing an architectural overview, it's always a dangerous thing to drive into with Istio, especially when you're talking about doing a survey or an overview, because at any point along the way, you can end up going down the rabbit hole. And so what I think, and I found an effective approach to this, is we're really going to try to stay as close to the 50,000-foot view. We'll dive in a couple places. But I think it's really fundamental as you're starting to use Istio to understand what all the various components are, how they connect together. I know that there are some follow-on sessions that are scheduled for later this year that are going to dive a little bit deeper into these various components. So if you don't get all of your questions answered today on those components, you can always hit us up offline and make sure to tune in for the future talks that we're going to have and really dive deep. So in the architectural overview today, one thing to keep in mind is that Istio, if you didn't attend the talk by my colleague Karthik Prabhakar last time, he did an overview of kind of what Istio was, and I just want to remind the audience kind of what we're dealing with here in terms of the service mesh and what Istio is. So let me make sure that I can switch slides here. Give me 1 second. There we go. So first, a little bit about myself. I am a senior solution architect with Tigera. I'm based out of New York City and handle clients on the East Coast. So if you're in this area or ever pop into the city, you want to stop by and have coffee or say hi, please don't hesitate to reach out to me on Twitter at McCodeman, and I'll have all my contact information at the end of the presentation. So why Istio? Why do we care about this idea of a service mesh? So as we move and start adopting modern practices for doing cloud native development, using microservices, distributed architectures, etc., we're starting to see a lot of new challenges that come from that, right? Operators and developers need better ways to do network traffic management. There's a lot of common patterns out there that we really don't want our developers to implement because either they're going to do it wrong or it's just wasted effort in re-implementing these patterns such as retries and circuit breakers, load balancing, etc. We also don't want developers re-implementing over and over authentication and authorization, right? We want that to be a standard part of the stack and something that we can plug into on the fly in terms of doing our authentication and be able to observe headers in HTTP and pass around bearer tokens and ensure that we have encryption on the wire, those types of things. We also want to be able to observe what's going on, right? So we really care about when you have hundreds of instances of microservices talking to hundreds of instances of other microservices and fairly complex call graphs, being able to debug that in production can be a challenge. So we really need tools that help us with distributed tracing and logging, et cetera. I wish I would have put a post of this in my presentation. I need to add this, but Kelsey Hightower made an interesting tweet this last week, talking about open interfaces, and I really agree with him on that open interfaces are the way that we're going to be able to move quickly in this open source world, right? The implementations don't necessarily have to be open source. In the case with Istio, most of these components are, but as long as we have the open interfaces and things like distributed tracing, for example, as long as we have a way to interface, with that framework and, for example, recording calls along the graph with that open interface, and it gives us a lot of flexibility in being able to plug in implementations in on the back end. And that's really what's going on with Istio. Is it's a framework that's going to pull a lot of different pieces of software together and provide all the open interfaces and plug-in patterns for connecting these pieces to form a service mesh. So this isn't an introduction about really the use cases about Istio. I encourage you to watch the previous presentation on that, but what we're going to do is jump straight into the architecture and start looking at some of the components that make Istio. So first thing I want to talk about here is the Istio Control Plane. You'll see this picture quite a lot when you look on the main page. It's there. A lot of folks that will use this picture when we're talking about Istio. And the key components here are the pilot, the mixer, the auth, and then the Envoy service proxy. And the thing to think about when you're thinking about Istio is it eats its own dog food, right? It's a distributed architecture itself. So every specific component has a specific concern. All the concerns are separated in a nice way. And there are multiple projects in the GitHub repository, and I'll try to show a picture of that and dive into that here at the end of the presentation, just to give you an idea where to start poking around and looking at the source if you want to get involved and start really understanding how the internals work. So each one of these boxes at the top here on the control plane are actually a separate GitHub project within that repository. So, or within that organization, rather. So Pilot is responsible for configuration. So when you're setting up your service mesh, there's a lot of things that you really care about. Say, for example, you want to establish how traffic is routed to a service or an endpoint. Or say you want to set up various policies that control how much traffic is routed to an endpoint. All of these pieces of configuration information are handled by Pilot, and Pilot is also going to be the interface that connects to various other orchestrators. Most of the examples here today that I will do will be associated with Kubernetes, but Pilot is a translation module between the metadata of Istio and other orchestrators, and we'll dive into that here in a minute as well. Mixer is a real-time calculator and aggregator, and it allows you to run custom code in flight in the path of the data, right? So as data is coming through on a request, if there are various rules that are matched on that traffic, right? So maybe who the request was directed at, what types of headers were in that request. It may deal with, matching on various types of traffic or ports or authentication, bearer tokens, those types of things. Mixer rules can fire, and various attributes can be collected about that request. And those attributes then can also be ran through other engines that determine things like quota management or filtering rules, or it may even trigger external actions like logging or authorization decisions that need to be made. And the results of that mixer calculation or that mixer, the run of that mixer task then can affect how that request is handled, right? Things can be allowed, denied, etc. One of the nice things that Istio provides kind of out of the box is this idea of enforcing mutual secure communication between services, right? It uses MTLS. And when you set up a TLS transport, as if any of you have ever done that before, you know that you start with a certificate authority, and there has to be a private key, and you've got to generate a certificate signing request and get that signed by the certificate authority, and ultimately end up with client and server keys and such, so that the public handshake between two different services can be done in such a way that they can establish an encrypted communication channel. So AUTH helps to simplify that for us. AUTH is able to take two different services that are in the same Kubernetes system and use Kubernetes principles, such as its certificate authority, and to provide a mutual authentication source. So both services are looking upwards to Kubernetes CA to establish their identity. And this is very important in situations where you may have, I work with Tigera, so we do a lot of network policy control. And so that's all at layer 3 and 4. And sometimes you also want to have policy protection at layer 7. And knowing that you're talking to the right person, you think about use case scenarios like IoT devices that may have, changing IPs and such. Having the capability to verify that the communication is and identify the endpoint using a TLS certificate is very powerful when you can't always rely on an IP or another lower stack identification mechanism. And this is the most interesting part, and I think Envoy is really what has powered this movement here. Envoy is a very small, lightweight, but very performant web proxy that sits within every single running pod as a sidecar. Envoy was developed at Lyft. It's been in production for several years now, and is a very stable way to proxy traffic from various apps and services that are sitting in a pod and basically route traffic on their behalf. The reason this is great is now it allows us to do, for our developers to write apps where they don't really have to be aware of the underlying transport mechanisms and how I'm actually going to discover the service that I want to talk to, send traffic to that service, ensure that traffic is encrypted, ensure that traffic is load balanced and routed correctly, ensure that my retries are handled correctly, those types of things. Envoy is going to do that all on my behalf, and this becomes quite opaque to the calling application. So those were the main components, and I want to start with the pilot now. We're going to dive a little deeper into what pilot is and how it handles discovery for the platform. So pilot, first off, Istio is currently targeted and biased heavily toward Kubernetes, but it's intended to be a flexible platform that can be used across a multitude of orchestrators. And so what Pilot's going to need to provide us is an abstract canonical model that can help us keep track of things like endpoints and services and routing rules and all the other configurations that will make up our service mesh, and do it in a way that is compatible across orchestrators. So at the very top, it has a platform adapter that allows the metadata from Kubernetes or Mesos or Cloud Foundry or other types of orchestrators to be plugged in, and Pilot can install listeners that will watch the changes in this metadata. So let's use Kubernetes for an example. I create a container, I create a deployment for that container, and I deploy that, or I install that deployment into Kubernetes, and it goes about creating a bunch of pods to match the spec of my deployment and the replicas and such that I've specified. as Kubernetes is spinning up those containers, excuse me one moment. We were talking about the platform adapter. And so one of the things that as those pods are created and there's lifecycle events generated from that, there may be actions that we need to take in our service mesh. For example, as a deployment scales out, let's say. So I've got some type of a front end that I scale out, or a back end that I scale out. And I want the front ends to know that there's additional instances that can be used from a load balancing perspective by my front end services, right, as these back ends scale out. What that allows me to do then is to listen to those metadata events, and then Pilot can update configurations and inform the various proxies that are distributed as sidecars about the new endpoints that are available for a particular service. That's just one example. As other configuration changes are made, the system is eventually consistent, and so all the agents will update as they see those changes declared. Same idea with Kubernetes. It's a promise theory type system. You declare your configuration, and the pilot is going to render the canonical model for that configuration, and based on those lifecycle events, et cetera. And then all the agents are going to eventually come into the right state as they see those changes occur. The other thing that's important here to realize on these platform adapters is that canonical model that we're developing needs to be stored somewhere. And so in the next couple of slides, I'm actually going to walk through, there's also storage adapters, and in the Kubernetes case, we're actually able to use custom resource definitions to store all those configurations as they get created. So let's take a look at that. So configuration is just like in Kubernetes. It looks like a Kubernetes type configuration, right? Everything is versioned from an API perspective. This allows multiple versions of an API to be active at once and gives you a way to migrate and upgrade between API versions. The kind specifies the type of resource that I'm dealing with. So I've listed just a couple examples here on the right, things like route rules, destination policies, ingress rules, the mesh config. We're not going to go into a lot of detail on each of these rules. Just know that these are the ways that you will define various behaviors of the Istio mesh. And typically these are created as YAML documents. In the Kubernetes case, since these are stored directly in Kubernetes, you can either use istio-ctl or the Kubernetes command line tool, kubectl, to put these resources in place. However, there's some validation things that you want to be aware of that the kubectl tool may or may not give you. The nice thing is that Kubernetes is being extended, and a lot of features are being enabled with their API extension servers that will begin to allow validation. And so we may be able to even migrate more things into a native kubectl type interface as well. But this is how we get configuration into the system. If you really want to dive in deep, I suggest you take a look at the API project in the Istio organization on GitHub. You can see all of the protobuf definitions there that describe the various resources that make up the various APIs. When these resources get serialized between and moved around between the components, protobuffers are used. As you're communicating with Kubernetes API endpoints, obviously those can be serialized into JSON and then on disk. We can represent them as YAML, and they can be read by the various tools in that format. And then with Kubernetes, we're sending that off to the Kubernetes data store by a Kubernetes custom resource definition. So these are all defined upon the installation of Istio, and then these custom resources are used as an index, if you will, into the current configuration of the Istio platform as it runs. One other thing to note as well is as you scale Istio out, or you scale your Kubernetes cluster out, you want to be cognizant of how you structure etcd behind Kubernetes. because now that Istio is also using the custom resources within Kubernetes, there's a lot more demand and load on Kubernetes that go beyond just the Kubernetes control plane and the various controllers that are running there. So we've already talked about how we take, the metadata from various orchestrators, we serialize that, and then Pilot turns that into a canonical object model for us. So here again is another view showing how we bring that configuration into Istio Cuddle, and then it basically passes into the rules API, and that model gets created. I'm showing kind of just various diagrams of this so you can start seeing what the flow looks like of actually adding configuration into Istio. When we plug in our platform adapters, that abstract model gets rendered, and then it needs to get saved, right? So it's using that platform adapter there to pull events in from Kubernetes that will be aggregated with that model that may update that model. And eventually then we're going to store those in CRDs. And we could actually look at those CRDs with the kubectl tool if you wanted to actually see how that's being indexed into Kubernetes. But the thing to keep in mind is the Istio Cuddle tool is going to give us schema and config validation. If we were to take CRDs and write them directly into the Kubernetes API directly, there's a potential that you might misconfigure something in the syntax. For example, various rule syntaxes and selector syntaxes, those types of things that the value type might match. It may be a string, but the actual syntax inside that might be incorrect. So you're going to get a lot more validation support and schema support if you use the Istio Cuddle tool when bringing configurations into the system. And then finally, once we've got this configuration and it's available to all of our proxies, we need a way to configure those proxies. So Pilot has a discovery agent, and what the Pilot discovery agent does is it watches those CRD changes and it implements several interfaces, API interfaces for Envoy that Envoy then uses to configure itself. And so some of those things, we call them the XDS APIs. X meaning that you can change X for either the service discovery service, we've got the cluster discovery service, the listener discovery service, the endpoint discovery service. These are the APIs that Envoy uses to find out information about the mesh. What are the endpoints that are available? What are the services that are available and the status of those endpoints? How do I find other members of the mesh itself with the cluster discovery service? And then how do I find more information about how I should be configured, how I should be listening locally on my container, or what different protocols and transport should I be supporting, right? So the listener discovery service is going to provide a lot of that information. So let's look at it a little differently now as we keep diving deeper into this. Excuse me. So the lines that are in red represent a control plane, and the black lines are representing a data plane. I hope that you can see the colors on your screen. What we have here is I'm illustrating that we've already shown that as I submit commands via Istio Cuddle or kubectl, right, they're ending up in the Kubernetes API as custom resources. The other thing to note here is that in some cases, when we want to talk to external services or bring traffic into the cluster, we may want to use an extension of Istio as an ingress proxy or as an egress proxy to do that. Really, and we'll take an ingress proxy, for example, is really no different than any other pod. What it is, think of it as a pod running the Envoy, instead of running Nginx or another proxy server. And by the way, some of those other companies are actively involved in Istio, so those are going to be alternatives to Envoy as well. But out of the box, you get, with the Ingress installation, you get Envoy, and Envoy acts as a application proxy for inbound traffic in the exact same way that Nginx or HA proxy or Trafic or something like that would do. And it is directly connected to the service mesh. So it's going to have a controller that's going to look at Kubernetes ingress resources, just like a standard ingress controller would do, and reconfigure that ingress proxy to handle mapping. For example, if I have an aggregated API or something along those lines, I can still represent those as an ingress resource. And then when that request comes in, it's going to get routed and handed off directly to the agent that's going to service it, directly to that endpoint that's going to service it via the Istio service mesh. Now, something important happens here. For those that have been doing Kubernetes for a while, you're probably quite aware of kubeproxy. So kubeproxy doesn't go entirely away, but in a lot of times, as traffic is moving around with an Istio instrumented cluster, you're going to sidestep kubeproxy. Kubeproxy allows you to take a service VIP, and it maps that using a destination NAT, a DNAT, on every worker or master node within that cluster. And so the way that it works is an inbound request will come in for a service VIP. There will be an IP tables rule that will translate that VIP as it comes in, and then it will do a lookup on what are the available endpoints for that VIP. Kubeproxy did this Kubeproxy is watching for the available endpoints and rewriting IP table rules on the fly, and it'll pick one of those endpoints and then route the traffic to it. And then as the traffic returns, of course, it has to go back and back through the connection tracking table and natted back to the original requesting IP. Istio steps in and provides that function on behalf of kubeproxy. And so now when a application in a pod, say service A, is calling, and that should be service B, that's a typo on my part, but say that service A is calling a crossover to service B, and it needs to do a name lookup. So the request gets sent to the Istio proxy that's running as a sidecar that's going to make the request on behalf of service A to talk to service B. If Istio wasn't available, that request, if the DNS mapped to a service VIP, that would have been intercepted by a rule that kubeproxy had written into the kernel as an IP table rule. And then the endpoint would have been selected there. By having the Istio proxy make the request on my behalf, it also knows what all the active endpoints at any given time for a service are. And so it could just route the request directly on my behalf. Now I don't have to NAT because everything is being handled as a layer 7 proxy, right? So one of the big differences to think about between doing something with kubeproxy and doing something with Istio is the Istio service to endpoint translation is happening at layer 7, where kubeproxy's translation is happening at a lower level in the stack at layer 3 and 4, right? Because it's using natting rules where the proxy agent is actually servicing a request on your behalf up in user land, in user space at layer 7. That's always a distinction to be aware of. So let's look a little bit more about how the proxy gets configured. So the pilot agent, or the Istio sidecar, is made up of a pilot agent and the Envoy proxy. And we'll talk a little bit in a minute on how that sidecar actually gets injected. But suffice to say that that pilot agent in its current form, and by the way, this is changing, and I'm going to show how this is changing, but the pilot agent needs to initialize in the Envoy proxy. So one of the things it's responsible for is talking to the Kubernetes API. It can also talk to if you've got MTLS turned on, the certificate authority, and get the TLS certificates for that service established as that pod comes up. The unfortunate thing about that, though, is that requires then every sidecar to have multiple RBAC rules enabled when talking to the Kubernetes API, and we'd really like to limit that. And so one of the things that's being developed right now is to try to move a lot of that functionality to one of these XDS APIs and let Pilot Discovery handle the lookup of some of the configuration in the Envoy proxy. And so the listener discovery service is being extended and fitted with all the configuration information. So the Pilot Discovery will be able to make that call and cache that information on behalf of the Pilot agent, and it'll just use that XDS API via Envoy. The other advantage that has is right now in the way that it's set up, Pilot is the parent process of Envoy. And so if it needs to make configuration changes, it can make configuration changes and either do a hot or a cold restart and bootstrap of that proxy. And there are already some known race conditions, for example, in working with non-HTTP type connections and services, and we really want to iron that out so that when Envoy needs to take on a new configuration, it can do that in process without having to suffer a restart and a drop of connection state or something like that. So the Pilot Discovery service is, again, watching the CRDs and maintaining that canonical model that the Pilot agent reads and configures Envoy proxy with. When Envoy proxy needs to look up a service, for example, say it gets a request for foobar, it doesn't know what the endpoints for foobar are. It makes a request again to the Pilot Discovery service, and it asks for what are the services and what are the endpoints associated via the XDS APIs, so that it can then route the traffic directly to another pod, which will be intercepted by an Envoy proxy on the other side and unpacked and sent to the application. Again, this is all opaque to the application. So let's move into Mixer. Mixer is a very deep rabbit hole, and I'm looking forward to the deep dive on that as well. To kind of summarize it, and you'll also find this picture within the documentation on Istio. Think about the Mixer as a pluggable way to add additional functionality. So, for example, it can plug into a logging functionality. It can plug into metrics producing functionality like Prometheus. It can make authorization decisions. It can track how many calls have been made by a particular user. All of these types of functionality are plugged into Prometheus. I'm sorry, to Mixer, and it can also allow excuse me. It can allow all these various backends to share data between each other, and so it has this concept of various types of attributes that are created, and there are native attributes that come along with every request. And as those attributes come in, we may be getting attributes from Kubernetes. We may be getting attributes from HTTP itself, like, for example, what the protocol is or what the port was, what the headers were of the request. Examples of Kubernetes attributes that may come along on the call are things like the labels that are available. We may get things like the namespaces that the services were in, maybe even things like service accounts that they're running under. All of the metadata that Kubernetes could attach to the pod that's making that call, that can all be inherited and surfaced as attributes as that request is being made from one workload to another workload. I apologize. Our family's recovering from the flu here, so I will try to limit my coughing. So those attributes come through, and as they get intermediated and resolved by various plugins, this can actually be a cyclical process, right? So I might have an attribute come in, it may get resolved, it may refer to something else in its resolution, and then that has to get resolved as well. And think about it as almost like compiling a result set of attributes for a request. And there's different plugins and adapters that are doing that for us, like Prometheus and Active Directory, et cetera, doing these authorization decisions and logging. All of this is controlled by rules. Rules allow us to match specific traffic, and if that traffic matches a rule, and a lot of times we specify rules in terms of attributes on the request, and so if the rules match the attributes that came in, then I can trigger different types of actions to occur. So for example, I could trigger the increase in a quota amount, or I could trigger an authorization decision to occur. And so that all happens inside of the mixer. Some examples of these attributes are listed here, right? So I might capture the HTTP request path. I might capture the size of the request or the time of the request, potentially the source IP or the service name, etc. And again, the list of attributes is actually quite lengthy. There's a lot of default attributes. You can also add your own, right? So if you're able to take the existing information that's coming in and then synthesize that with a service on the back end, then you can publish your own attributes that then can be used downstream of a request, and it will just get carried along with that request as it moves downstream. And the final thing that I want to discuss today is the authorization. Kubernetes has a built-in mechanism for allowing its CA to sign additional authorization requests. And this is actually really quite simple. The pilot agent can call out to the certificate authority. A CSR can get created on the fly. And as long as the correct permissions are in place, that certificate authority then can sign the request, and now I've got the certificates that I need to do mutual TLS authentication. So now let's take a quick look at how SIDECAR injection works. There's two different mechanisms that I can use to inject the Istio SIDECAR. One of the things that you don't want to have to do if you wanted to install Istio in your cluster is you don't want to have to go and manually add all of the specification information inside of a Kubernetes deployment or a daemon set, stateful set, etc. You don't want to go in and have to manually say, install the init container, and here's the configuration for it, install the Istio SIDECAR, here's the configuration for that, so that your container comes up. It's really nice if you could auto-generate that. And Istio does provide a mechanism that allows us to auto-generate all of the SIDECAR information. This actually could be really useful for something like a CI/CD pipeline, if you wanted to do other types of validation, or you wanted to restrict the way who had the capability of actually injecting the SIDECAR, participating in the service mesh. One of the ways that you could limit that is do the injection manually within your CI/CD pipeline, and then publish the resultant YAML after the transformation to Kubernetes. However, a lot of times you just want everything to automatically be injected, right? You want everything to participate in that in the service mesh. And so now we have the capability of doing this automatically. If you're familiar with the way that Kube API server works, anytime a resource or a request comes into the API server, there's a series of admission controllers that run things such as making sure that you're authorized to actually make the request, things that can actually look through the request and see if there is anything that invalidate or is not valid, in regards to a policy that your organization has set up. One of the examples may be, you're only allowed only certain containers with a certain signature are allowed in, from a assigning authority, or you may have a controller that limits what labels can be applied to a pod. In addition, there's a thing called a mutating admission webhook, and you want this webhook to run before the validating webhook, because after the injection occurs, you still want Kubernetes to validate your resource as a valid resource. And so this runs before the validation hook. And what the mutating admission webhook does is it is registered with a admission registration resource. So during the installation of Istio, if you look through the installation files, you'll see this admission registration mutating webhook configuration resource getting created. And it provides all the information that basically points at the service of the Istio sidecar injector. It also can be horizontally scaled as well. And all it does is take the configuration that's coming in, and based on the configuration you provide it, will automatically generate all of the additional configuration for the deployment or the daemon set or the stateful set that's needed to ensure that the Istio sidecar is injected. And then that is basically returned back up to the API server. The processing continues, and eventually that resource gets created. And so that's how automatic sidecar injection works. So that's going to bring me to the end of this, because I think after we've gone through all of the major components that make up the control plane. What I didn't do is I didn't do a deep dive into the Envoy proxy, because I know that there's a future session coming up on that. But suffice to say, the Envoy proxy, basically gives us all of the, these capabilities of doing the traffic management, and a lot of these patterns are built into that. And so as the project matures, there's a lot of features inside even the Envoy proxy that are not fully utilized by Istio yet, and a lot of growth that can be done there. As always, there's a lot of different work streams that are going on in Istio, and there's a I believe is it a weekly call now that's happening to update folks on all of those activities.
Is that the community call?
It is the community call, and I didn't put a link to it. I should have, but I really encourage everyone. It seems like a daunting project because there's so many moving parts, but the community is very accepting and would love to get you plugged in. There's a lot of help wanted activity available right now in the repository, and so if you need help on knowing who to contact or whatever to get in, please reach out to me, reach out to Matt, reach out to any one of the sponsors, and we'll definitely get you plugged in and get you some help.
Yeah, and I'll post the link to the community meeting that happens every week. I'll post that to the meetup page. So for anyone that wants to start joining that, it's on. I believe it's on Thursdays, 11 a.m. Pacific.
Right.
If I'm not mistaken.
Right.
Cool. Thanks, Cody.
So I'm available for any questions now, and just wanted to my shameless plug here is that we do offer additional training with Tigera. So if you're interested in checking that out, or want to reach out to me on Twitter or GitHub, please do so.
Cool. So I have a few questions. So there are a few questions. I'll start with the first question, which is, so the user asks, we have an existing PKI where we use the OU of a cert to indicate a role or group. Can we configure Istio to support this? For example, app equal front end has a cert with OU equals front end in it. It wants to talk to app equals backend, which only allows connections from MTLS clients with OU equals front end in the cert. Are you able to do that with Istio?
I think that there is a pluggable capability that's being developed for that. There's also additional Istio service RBACs resources that are being developed. I have not dove into those deeply yet, but I do know that those are being worked on. So I think the answer is yes, but I would definitely want to take that offline and see if I can provide some more detail. Okay,
and I think maybe we can encourage people to join the community, and that might be a good spot to ask that type of question to figure out which.
Certainly, and there is a I don't know if the Slack is open yet, but you can ask questions. I think on the Kubernetes Slack, there's a lot of questions that get asked there. So yeah, definitely join, and if you're active in it, we can get you plugged into that.
Okay. So the next question is, how does Envoy capture the application running as a service logs?
How does Envoy capture the application running as
service logs?
Oh, how does it get the service logs?
Yeah.
Okay, so one of the ways that you can do it is there is a Fluent integration on the back end of the mixer, and you can actually set up a rule to match different types of traffic that will generate a Fluent stream or a Fluent request, and then that can get routed back to Elastic or however you want to capture those logs. And so the nice thing about doing it via the mixer is you can add a lot of additional attributes into that log that gets written out that may span more than just the service producing the error or the request.
So another question came in from Tomas. So Istio doesn't use Kubernetes services and kubeproxy in a classic way. Is all communication happening between Envoy using the pod's IP address?
Yes. And so it's able to look up that IP address and directly make those connections. That doesn't mean that kubeproxy is not required. There are still other parts of the control plane within Kubernetes that are going to be relying on that.
Okay.
And so you still have to have kubeproxy installed. But yeah, Envoy can short circuit some of that natting that takes place.
Okay. Does that answer your question too, Murthy? There's a follow-up. Okay. Cool. And then I also had a question on, so you had a comment on etcd and increase in load when you add Istio into the environment. Is there any metrics on the percentage load increase that Istio would introduce to etcd?
I don't have those numbers. And most of the time, if the load is going to be directly proportional to how often you're cycling services or containers,
mm-hmm.
and if those containers are cycling often, then obviously you're going to be making SDS updates and endpoint updates. The discovery has to to see and pilot has to write back into the database. It's not going to be a huge increase. Most installations are fairly quiescent, I would imagine, but it's something to just to keep an eye on.
What's the largest installation of Istio? Like the largest Istio installation you guys seen so far?
I don't have the specific number on that.
Okay.
We've been playing with fairly large ones, but I don't have the specific numbers for you today.
Okay. To let everybody else know, we're going to actually be going into user production stories here soon. We do have some brave souls who will publicly talk about this stuff and how they're using it. So there'll probably be a lot of interesting questions in there. I always have a question around upgrades. Those are handled right now, but cool. So thank you, Cody, for speaking today. Thank you everybody for joining us. Just let everybody know we are going to clean up the video, and then we'll get that posted in probably the next few days. The last one took us a little longer as we were kind of figuring out how to video edit and clean things up. But now we know how to do that. So we should have this out there soon. And we'll circulate it over our personal Twitter accounts. There's no real Twitter account for this meetup. So if you want to speak about Istio, or you want to talk to either Cody or I about Istio, just drop us an email, drop us a DM. Hope to see you next time. Thanks.